So as we discussed earlier, we need to find the maximum support spacing or the span length of the plywood, studs, and wheels based on bending, shear, and deflection. So we need to find the design shear, maximum bending, and maximum deflection on the member. In order to find these, we need to find the distributed load per foot. But we have the lateral pressure of concrete, C of Cp max, that we discussed earlier in section 5.4.3. And these are given in pound per foot squared. So we need to convert the concrete pressure in pound per foot square to distributed load, pound per foot, for the studs, wheels, and plywood to find the design shear, maximum bending moment, and maximum deflection. So these are the main component of the Formwork system we discussed earlier. We have the sheathing, the studs, the wheels, the ties, and we have the base plate, and we're going to be pouring the concrete. So the concrete is going to have a pressure, C of Cp or C of Cp max, given in pound per foot squared, which is going to be translated into distributed load per foot, W, on the sheathing, studs, and wheels, and which is going to be eventually translated into tension in these ties holding the Formwork system together. So the first distributed load per foot we gotta find is for plywood. We have the concrete getting poured and we have the sheathing in contact with the concrete. So there is concrete pressure on the sheathing, and we gotta convert this concrete pressure to distributed load per foot on the plywood, known as W plywood. In order to do that, we need to assign a tributary area. We gotta assign a width of the tributary area. That width gonna be 12 inches, and the reason for picking 12 inches for the tributary area is because the effective section properties for plywood given in table 4.13 we discussed earlier is given for a 12-inch wide strip. And these effective section properties are moment of inertia, effective section modulus, and rolling shear. So you want to relate the strength of the plywood represented in these values here in table 4.13 to the demand on the plywood, which represented by the tributary area. So both width gotta be the same. So we have 12-inch wide tributary area, and we're gonna find the W plywood, or the distributed load on the plywood, to be the concrete pressure multiplied by the width of the tributary area, which is 12 inches. So we gotta assign or think of the 12-inch wide plywood as a beam supported by these studs up here. Then we gotta apply the bending, deflection, and shear limit state for that 12-inch wide strip of plywood to find the maximum spacing of plywood supports, which are the studs. So we apply these three limit states, we find the maximum spacing of these studs, then we pick a specific stud spacing, then we move forward for the next step. So similar to plywood, we need to find the distributed load per foot, W, for the studs. So we have concrete pressure on the sheathing and the studs supporting the sheathing, so there's pressure on the studs. We found earlier the spacing of the studs by applying the bending, deflection, and shear limit states on the plywood. So we know the spacing of the studs, and we gotta assign a tributary area for the stud, and that tributary area width is going to be the spacing of the studs, obviously because the studs are uniformly spaced. So your distributed load on the studs is going to be the concrete pressure, C of Cp, multiplied by the spacing of the stud we found earlier. We found the distributed load on the studs, and we think of the stud as a beam supported by these wheels up here, which represented by these pin connections, and we apply the bending, deflection, and shear limit states for the stud member, and we find the spacing of the stud supports. or the wheel's spacing. So we find these spacing here by applying the bending, deflection, and shear limit states, and we find the spacing of the wheels. After that, we move to the next step. Moving for the wheels supporting the studs, we gotta find the distributed load per foot for the wheels. In order to do that, we gotta assign a tributary area for the wheels, and we gotta assign or find the width of the tributary area. That width gonna be the spacing of the wheels, which we found earlier by assigning or finding the deflection, shear, and bending moment limit state for the stud member. So we know the spacing of the wheels, so we know the width of the tributary area, and we can find the distributed load per foot on the wheel, which is going to be the concrete pressure times the spacing of the wheel. And we think of the wheel as a beam supported by the ties represented by the pin connections, and we apply the bending, deflection, and shear limit states for the wheels to find and pick the spacing of these wheel supports. And the supports of the wheels are the ties, so we're finding the ties spacing as tie. After we find the spacing of the ties, we move to the next step. So the last step is to find the demand load on the ties supporting the wheels. And this demand load is basically the tension in the ties. So in the previous step, we found the spacing of the ties and we found the distributed load of the wheels. So the tie load is simply the reaction forces resisting the wheel distributed load.